Hello and welcome to the Encore Research Group podcast, where we encourage community research and education with weekly podcasts. I'm your host, Benton Loeyball, and this week we're talking about a dangerous type of fat in the bloodstream. Elevated lipoprotein a, causes, risks, and management strategies. Why did the dad name his cat Lipid? Because it shuns water, and if it ran around in the bloodstream, it would be detrimental to your health. Sorry, but the authors are a new dad and an old dad, and we can't help ourselves. Lipid is a medical term that refers to fats that circulate in our bodies and have functions in our cells. Think about cooking oil, a fat similar to lipids, and our blood, which is very watery. Having oily lipids loose in the bloodstream can lead to myriad problems. Lipids or fats are critically important to the running of a functional body, and we need them delivered all over using the bloodstream. In order to declaw these water-hating critical lipids in the bloodstream, we need to package them up into a nice safe box, just like a cat going to the vet. How do we solve the fat and water problem in our blood? Apolipoproteins come to the rescue. Lipo refers to the aforementioned lipids, and protein refers to proteins. Together these form a complex, and the apo at the front specifies that we're talking about the protein part of that complex. These proteins surround the fatty lipids and make nice, safe packages that's part lipid and part protein called a lipoprotein, made of cholesterol carried in apolipoproteins. Along with providing structure to the lipoprotein, apolipoproteins also help form a special membrane to keep the lipids inside, signal to other molecules to tell them what the lipoprotein contains, guide the metabolism of lipids, and help keep our bloodstream safe with the lipoproteins. Well, not perfectly safe. A good package is a high-density lipoprotein. A bad package is low-density lipoprotein. But even more dangerous is lipoprotein a, abbreviated Lp(a). Clinical trials helped find medications like statins to lower LDL, but these have little effect on Lp(a), so current clinical trials are studying ways to lower levels of this really bad cholesterol, as well as the health effects of reducing Lp(a). High Lp(a) levels are dangerous and unfortunately hard to control. Your risk of having high Lp(a) is genetically determined, though some medical and environmental conditions can affect Lp(a) levels. APO(a), the apolipoprotein that creates Lp(a), is a long chain-like protein. Different people can have different sized chains called different isoforms, which may be bigger or smaller. According to Dr. Michael J. Koren, MD, and Dr. Albert Lopez, DO, the smaller isoforms tend to be more numerous and dangerous. What determines the size of the isoform? Our genes. Our genetic code directly determines the size of our APO(a) apolipoprotein and the concentration of Lp(a) in the blood. These genes barely change over generations, so people with similar racial or ethnic backgrounds have a higher chance of similar Lp(a) levels. Those of African or South Asian descent tend to have higher Lp(a) levels than those of white or East Asian descent. So why are high levels of APO(a) or Lp(a) dangerous? There are three major complications from the bad cholesterols LDL and Lp(a). High levels of bad cholesterol increases plaques in the bloodstream, being pro-atherogenic, leads to blood clots, being pro-thrombotic, and promotes inflammation, being pro-inflammatory. The end result is an increased chance of heart attack, stroke, and similar conditions. Levels of bad LDL cholesterols are kept in check by LDL receptors in the liver, but Lp(a) does not get cleared by LDL receptors. This means that elevated Lp(a) can be very hard to manage. Since levels are genetically determined, diet and exercise don't have much effect on Lp(a) levels, though they can have a great effect on mitigating complications. Additionally, typical LDL-lowering cholesterol medications like statins have little effect on Lp(a). PCSK9 inhibitors are a class of medication that increases the systems that degrade LDL and may help lower Lp(a) levels. Unfortunately, as of writing, no medications have been FDA approved for lowering Lp(a) levels and improving cardiovascular disease outcomes. However, research is ongoing to find safe and effective treatments for Lp(a), with some findings possible in the next year or so. Some of these investigational medications include antisense oligonucleotides, or ASOs, which go to the source, stopping genetic code from producing excessive APO-A. Other investigational medications called small interfering RNAs or siRNAs break down mRNA molecules to prevent the assembly of Lp(a). This is an exciting space that has real promise for improvement to make our lives easier and more pleasant. Clinical research is the key to discovering how to lower blood levels of these dangerous, fatty, water-avoiding lipoproteins. Call your local clinical research office or visit clinicaltrials.gov to find research opportunities for elevated Lp(a) and other conditions. Now, if we could just study how to make my cats enjoy taking a bath. There's more to this story when it comes to Lp(a). We have many intriguing podcasts, videos, and other articles on this really bad cholesterol at medevidence.com. Thanks for joining us on this week's episode. If you'd like to know more, all of our sources are linked in the podcast description. You can also visit our website at encoredocs.com. That's ENCOREDOCS.com. Encore Research Group has been involved in clinical research for over 25 years. We have 7 clinical research sites across Florida, including 2 Phase 1 units. If you're in Florida, join us at sites in Northeast Florida and on the Nature Coast. If you're outside of Florida or South Georgia and are interested in joining a clinical trial, head over to clinicaltrials.gov. For more great content, including discussions by physicians and clinical research experts, check out the MedEvidence podcast. My name is Benton. Thank you for joining, and we'll see you next week.